In today's lesson, we are going to be looking at simple and compound interest. So we've looked at these topics previously in previous lessons. We're going to be looking a little bit further on them. We are going to review simple interest a little bit, but we're going to then primarily focus on compound interest. So interest is when you invest or borrow money. Interest is a factor. So interest rates are quoted usually as a percent per year or per annum. So when we see something that says like 5% PA, that means basically you're earning 5% interest per year. So the interest is an additional amount that gets added on to your starting value. If you're borrowing money, it's an additional amount that you have to pay. If you're investing money, it's an additional amount that you've earned. So again, depending on the situation, you may have it may benefit you or it may kind of hurt you. So simple interest is only calculated once at the end of the term, and it's only focusing on the principal. So in the formulas we see here, we've looked at these before. I equals PRT. The interest, or I is the interest earned, P is the principal or the initial amount, R is the rate as a decimal, T is time in years. And if we want to figure out the total amount that we have, we would take the principal plus the interest and add them together. So the second equation is almost more common sense compared to the first one. So let's just take a quick look at an example. So Sam borrows $500 from his Aunt Sally. Sally charges him 4% PA. How much will Sam owe her after a year and a half? So we can go through and fill out the values that we know. We don't know the interest. That's what we're trying to find. We do know the present value is $500 because that's how much he's starting with, or that's how much he's going to invest or save. Or not invest, sorry. That's how much he's borrowing, so that's how much he's going to owe. The rate is 4%. Because we need to turn it to a decimal, 0.04. And the time in years, because they're looking at a year and a half, it's 1.5. So again, we find all of that directly from the question. And again, we don't know the interest, but that's what we're trying to calculate. So I equals PRT, 500 times 0.04 times 1.5. And it just becomes a calculation. In the end, we should get 30. So that means he's earning, or there's being $30 of interest added on to his loan. So we want to figure out how much Sam is going to owe her. So we want a total amount. So I plus P, or P plus I. So $30 in interest earned plus the $500 original equals $530 total that he'll owe after a year and a half. So from borrowing that money, he's going to have to pay an extra $30 over that year and a half. Look at another example. So Fred puts $1,000 into a bank account offering 9% PA. We want to know how much Fred will have after 200 days. So the I value, again, we don't know. The P value, he's putting in $1,000. That's the initial amount. That's the principal. The rate is 9%, which again, we have to turn to a decimal, so 0.09. You can divide it by 100, right? That's how you can turn a percent to a decimal. Divide the percent by 100. And the time, in this case, because remember, we do want it in years, we're given time in 200 days. I'm just going to highlight the other stuff as well, see where we got those values. I'm given time in 200 days. So how do I represent 200 days as years? Well, 200 days out of 365 is how we would represent it by years. So we can take 200, divide it by 365, and we end up with 0.5479. There's a few more decimal places, but that should be enough. So we have roughly about, you could say, 55% of a year, or 0.5479. So if you're given a value of time other than years, you would have to divide by how many of that unit there are in a year. Because there's 365 days in a year, that's why we're dividing by it, or the 200 by that. So to find the interest, I equals PRT equals 1,000 times 0.09 times 0.5479. In the end, again, it's just one calculation. We're multiplying three numbers together. We end up with 49.31. With money, we want to round our dollar amounts to two decimal places because we are looking at money again, right? So money always has two decimal places, so that's why we round there. So 49.31 is the amount of interest earned. To find the total amount, I'm going to take my interest, the 49.31, add it to the $1,000. Again, the second one is more common sense, so you might not even have to do an equation for it. But after 200 days, Fred is going to have $1,049.31. Moving on to compound interest. So in compound interest, it's calculated on a regular basis. So it's calculated over different periods, or what we call compounding periods. It's also interest on top of interest. So we've seen that before. We've looked at the comparison between the two. So we're going to look a little bit further at compound interest. When we look at compound interest, right, because it is on a regular basis, we just mentioned, on what we call compounding periods, we want to understand what the different compounding periods represents. In this case, if it's compounded annually, it would be once a year. Semi-annually is twice a year. Quarterly is 4 times a year. Monthly, 12. Daily, 365. Weekly is 52. And bi-weekly, or every other week, is 26. So those are what the compounding periods are. And we'll see that appear in questions because it will tell us it's compounded X amount, or it's compounded daily, quarterly, whatever the case may be. So that's also a key indicator that we are looking at compound interest rather than simple interest. So let's look at a simplified example. So Wilma puts $800 into a bank account offering 12% per annum compounded quarterly. How much will she have after a year? Well, let's work through it in a table. So in the first quarter, she starts with $800. The interest earned on the $800 is 12%, but because it's compounded, it's 12% over the year, it's actually, so if we take 12%, we turn it to a decimal, 0.12. So that's 1 year. We're looking at breaking that up into quarters. So I need to take 12% and divide it by 4. It's 0.03. So this is the amount of interest in 1 quarter. So that's, you want to be careful. There's one thing you have to do. So we want to figure out the amount of interest in 1 quarter. We have to take that interest rate and divide it by the number of compounding periods, which in this case is quarters or quarterly. So we start with that $800. We want to multiply it by 0.03. So we're going to find out what 3% of 800 is. $24. So our new balance at the end of that 1 quarter is $824. Now, in the second quarter, we have a new starting value, $824. We find 3% of that value. Because again, it's another 3% for the second quarter. And we get 24.72. So it's a little bit more, almost $1 more. Our new balance then is going to be 24.72 plus 824, get 848.72. That new balance then becomes our new starting value. So we have seen this before. We've seen this kind of buildup of interest. We're calculating interest on top of interest. That is the difference of compound interest compared to simple interest. So third quarter, we have a new starting value. To find the interest earned, we take that value, we multiply it by the 3% again, and we get 25.46 in rounding to 2 decimal places. So 25.46 plus 848.72, 874.18. And then again, finally, for the fourth quarter, the last quarter in our year, we start off with 874.18. We need to find the amount of interest earned, so we need to multiply that by 3%. So 874.18 multiplied by 0.03. We get 26.23. And in the end, we have $941 or $900.41. So after 1 year, Wilma will have had $900.41. It's a little bit different than what we would have done if we just had to do simple interest. Just doing a quick calculation, 18 times 12 times 1, only would have earned $96. So we've earned an extra $4 in the year by using compound interest compared to simple interest. And even though it doesn't seem like much, again, that's only 1 year, and it's $4 extra, right? If you want to turn down $4, then by all means, you can feel free to give it to me next time you see it. If you're not too concerned about $4, I think anyone would be happier with more money compared to less. Now, the thing about compound interest, we could go through and do a table like this and work through these types of questions in this format using kind of our idea of simple interest, right, multiplying the value by the percent and then adding it on. However, that can be very time consuming, right? This is only quarterly in 1 year. What if we looked at, say, 3 years and we looked at monthly? So we're looking at 36 different calculations, right? It's very time consuming to go through and do a table like this. So we're only using the table just to show kind of the basic calculations. We do have a formula for this, and it is a application of exponential models. Right? So we can see the equation here. This is very reminiscent of an exponential model, an exponential growth model to be specific, because we see that we have an initial amount P, we're multiplying it by a rate or a growth rate of 1 plus I, and it's raised to an exponent of n, or a variable. So this is our compound interest formula. A is the amount at the end of the question, or again, the future amount. P is the principal, which is again the initial amount. I is the interest rate per period. So similar to what we just kind of calculated, the interest rate per period, we have to take the annual rate as a decimal and divide it by the number of compounding periods. N is the number of periods in total. So in this case, we are taking the number of years and multiplying it by the number of compound periods. So we do have to do 2 small calculations before we can actually enter anything into this compound interest formula. So let's go back to Wilma, right? The future amount, that A value, we don't know. The principal, she started with 800. So we're just going back to that original question that we did with the table. The I value was 12%. We need to turn that to a decimal, and we need to divide that by the number of compounding periods. So because this was compounded quarterly, our compounding number is 4, because there's 4 compounding periods in a year when it's quarterly. So we're going to take that 12%, or that 0.12, divide it by 4, get 0.03, or essentially 3%. Now for n, we have 1 year multiplied by the number of compounding periods, which is 4. 1 times 4 is 4. So this one isn't too complicated, but you can see kind of the same numbers that we dealt with when we were going through and doing those calculations in that table. Now what we can use our formula. A equals P1 plus I to the power of n. So P is 800 times 1 plus 0.03 to the power of 4. So this becomes 800 times 1.03 to the power of 4. And you can kind of see how this formula comes about, because the 1.03 is essentially 1, or the initial value, plus a 3%, and it's raised to the power of 4. So that means we're multiplying 800 by 0.13, getting an answer. Multiplying by 1.03 again, getting an answer. Multiplying by 1.03 again, getting an answer. So it's kind of, you can see how this formula, when we break it down, is the same thing that we were doing in that table. So 800 times 1.03 to the power of 4, we get $941. So again, the same value that we got from the table. So this is just to show that that equation does work. It's a lot simpler to use this formula rather than going through the table. Now you're going to see compound interest a lot more. That tends to be the more common one. So that's why when we look at things later on, we tend to focus on compound interest because it is more common. You might earn more when you're saving with compound interest, but with banks, they also earn more when you borrow with compound interest. So they want to make the most profit themselves. That's why they use compound interest and have higher rates than what you would save with compound interest and lower rates. So one last example. So Brad borrows $1,500 from a bank at 6% per annum or per year, compounded monthly. How much will Brad owe after 2 years? So let's go through and fill out our missing variables. A, we don't know, that's the future amount. We're not sure what that is yet. That's what we're trying to find out. The present value, or the principal, is $1,500. That's how much he's starting with. That's how much he's borrowing. So that's the initial amount of the loan. The I is 6%, because it's 6% per annum, but it's compounded monthly. So again, that's key because that tells us, 1, it's compound interest, and 2, it tells us the compound number, or compounding periods in a year. So the compound number in this case, because it's monthly, is 12. There's 12 compounding periods in a year. So for that I value, we do have to do a small calculation, turn it to a decimal, and then divide by 12. So in this case, our I value is 0.005. So that's our I value. Our N value is the number of years. So it's after 2 years. So 2 years times 12, because there's 12 compounding periods in a year, equals 24 total compounding periods. Now we can use our formula. A equals P times 1 plus I to the power of N. 1,500 times 1 plus 0.005 to the power of 24. So 1500 times 1.00, oops, too many zeros, 005, power of 24. Again, when you're solving using a calculator in this case, especially if you're using a phone calculator, make sure that you're solving the exponent first, right? You have to do the 1.005 to the power of 24 and then multiply that by the 1500. Do not multiply the 1500 times the 1.005 and then raise that value to the exponent. You'll get a very, very high number that probably won't make sense in terms of saving money or owing money over 2 years. Right, so again, you do have to follow BEDMAS, so just be mindful of that when you're solving. If you're using your phone, chances are you probably have to do the exponent first, or the exponent term first, and then multiply. If you're using a scientific calculator, as long as you enter it correctly, it should be okay. So we then have an A value or a future value of 1,600 or 1,690 and 74 cents. So this means that after 2 years, Brad is going to owe a total of $1,690.74 for his loan of $1,500. So that's kind of the downside. When you borrow money, you have to pay a bit extra back. Right? That's the cost you pay when you borrow. So again, the main thing from this lesson, we have looked at simple interest and compound interest in general before, but now we have a formula that we can apply to compound interest to make it a little bit easier. Right? Rather than having to do the tables, we do have now the formula that we can use. So don't forget what the values mean, as well as the 2 small calculations that you have to do beforehand before you can actually use the overall one.